I'm going to jump into the next topic. So we're going to speak on the Almond Irrigation Improvement Continuum, which is a publication the Almond Board produced a number of years ago that really is designed around helping you advance through your practices of irrigation management. And then we'll look at some quick tips on distribution uniformity. So a little review, just what I just said here, and we'll move on. So the Almond Irrigation Improvement Continuum it's about 150-page publication that was put together as a partnership with a number of people at UC Davis. Great input from farm advisors and A&R people at UC Davis that authored this publication alongside with the Almond Board. It focuses on 5 irrigation practices and tracks 3 different levels to move you through as a grower to improve from a fundamental stage up into some advanced techniques. This is available both as a PDF, which there's the link here on the side. If you go to almonds.com/irrigation, you can download a copy of it. And we also can send out print versions. If you're interested, I will share an email address at the end here on how to get a copy of it. But it's a very comprehensive manual to irrigation. Being an irrigation designer, it was exciting to see. I was so used to irrigation books being about how to design an irrigation system. This is really around how to use an irrigation system, which is a big difference. So it's broken up into 5 key practices that really feed into making your final management decisions. So starting with the irrigation system first. So really, how uniform are you delivering water? How efficient is the irrigation system? And evaluating that before you get started with the other practices. And then looking at water use. So how much evapotranspiration is taking place in the field? So how much water are your trees utilizing? What do you need to replace? Understanding that and finding out how to solve that problem of understanding that. And then understanding what your applied water is. So some steps on calculating your applied water. In some cases, growers are just the irrigation company that designed their system says this is what your system applies, but the Continuum takes you through a process to decide that on yourself and measure that yourself. And then looking at monitoring. So monitoring soil moisture, anywhere from an auger, using a hand auger out in the field, to telemetry systems and soil moisture sensors. And then looking at plant stress. So visual cues on plant stress, as well as using a pressure chamber to measure plant stress or other plant stress sensors. And this all feeds into making final decisions on how to change your irrigation schedule to meet your tree's needs. So working off those 5 practices, the Continuum walks you through 3 different levels from fundamental to advanced on more sophisticated approaches to solving these problems and answering the questions. The level 1 are practices within reach of any almond grower. Level 2, more sophisticated, and then level 3 are practices that are really going to help maximize that crop per drop of water that you're putting out. So when we look at the evaluating the system's performance, irrigation system, we really want to know that we're starting with a really well operating and efficient irrigation system. So looking at this level 1, we're looking at just going out and spot checking pressures throughout the orchard to see that you have consistent pressures being delivered in the orchard, and then calculating an average application rate. As you advance through the continuum, we would move into doing a broad distribution uniformity evaluation of the orchard, where we're checking not just pressure, but also flows, and then measuring that application rate. And for these first two practices, or levels, we encourage this to be done every 3 years. And then finally at level 3, increasing the frequency. So doing it every couple of years. So your irrigation system doesn't have an opportunity to kind of degrade, but it's operating well all the time. And 2 years is a pretty good frequency. So then moving on to determining water use. So the first one is just understanding what the orchard's water requirement is. And at level 1, using just historic ET, normal year ET data to estimate what the crop need is. As we move along, pulling in current weather data and factoring in for cover crop use. So that's going to impact your water use, so factoring in cover crop use. And then finally, using real-time data collection of ETC data, using a tool like the irrigation calculator within the CASP program would give you this real-time data. And then you can see there's a frequency change at each level from monthly to bi-weekly, getting higher resolution data. And then we're going to move on to determining what flow, capturing what the actual flow is. So you can start off at level 1 of having a numeric application rate. Maybe this came from the irrigation company that says you're applying so many inches per hour, and multiplying that times your duration would solve the problem of how much water did I apply. But the next level is really measuring that with a flow meter, putting a flow meter in place and actually measuring it. And then finally at level 3, comparing that, what you're applying to what the ETC recommendation is to determine your efficiency of the irrigation. Then as we move along further down the continuum, we're going to look at actually monitoring things in the field. So the first is soil moisture, using a soil auger to actually pull pull soil from the ground down to 3 to 5 feet, and using the hand field method to determine how much moisture is available in that soil. And I actually recommend a soil auger through all the levels. I think a soil auger is one of the most important tools that you have in your pickup, because when you move on to level 2, where you're using a manually operated soil moisture system, where you're going out and there's sensors in the field and you pull readings off every couple of weeks. If you use the auger, it's going to allow you to trust that that sensor is correct. A lot of times when I've worked with growers that they start using soil moisture sensors, the data coming off the sensor sometimes isn't what they expected, and they don't trust it because it wasn't what they expected. But they're usually right. So the way to solve that is to actually continue using an auger as a spot check to validate that your sensors are providing good data. So I really recommend continuing to use the soil moisture sensor. And then lastly, moving into the most advanced level, level 3, using an automated system that's remotely reading your soil moisture data, delivering back to an application. Most of these platforms provide you information every 15 minutes, but reviewing it weekly. So like in the other practices, the frequency of following the practice is getting more resolute. So at level 3, we're looking weekly and using an automated system that captures that data, stores it for you, and then delivers it to you over the internet. And then looking at plant stress. So at level 1, we're just looking at visual clues, going out in the orchard and looking for clues in the tree to determine what kind of stress the tree is under. As you progress, using something like a pressure chamber to actually measure stem water potential, so you can make a measurement that tells you exactly how much stress that tree is under. And then in level 3, moving on to using a baseline and using that data to determine when to start your first irrigation. So like in the other practices, we're moving from fundamental to advanced. So each step adds a little bit more resolute and different technology to capture that information. And then pulling all those 5 practices together, really leveraging data from each of them is going to help adjust what your irrigation schedule is. And this is moving through different stages of doing that. So if your practices are level 1, you're using your soil auger data where you went out and did a hand field in the field with a visual examination of tree stress to determine and adjust your schedule. Moving into level 2, you're using more data, more inputs to help determine that. And then at level 3, you're actually using real-time data to help adjust that schedule. So getting you to more efficiency, more resolution, higher level of input to help you make that management decision. So those are the practices around the continuum. In this manual, I really encourage you at least to get a downloaded version of it. But if you'd like a physical copy, we can get that to you as well, because it really will help you improve your efficiency of irrigation. Now we're going to kind of talk about distribution uniformity. And you're going to discover this by using that first practice of evaluating your irrigation system. Really, the goal of distribution uniformity is to evenly distribute water across the whole orchard. So the trees at the very end, the last ones to get water, are getting a similar amount of water, or the same amount of water as the trees nearest to the pump. So you can have things that cause issues with that. And going through these evaluations really going to help solve and find what those issues are. So this is a quote, and I really like it, from Charles Burt of the Irrigation Technology Research Center at Cal Poly. This is a quote that came from the California Irrigation Institute's conference. Approximately 55% of crop non-uniformity is caused by irrigation system distribution uniformity. This is a really profound statement. And when we look at trying to reach this goal of reducing the water to produce a pound of almonds by 20%, this is one of the fastest ways to get to that, because our systems over time have issues. They have clogging issues. Things just wear over time. So I really like this quote and take it to heart when I look at uniformity. So some common things that cause problems, and this is a list from that the Tehama County RCD put together of uniformity tests that they had done across Northern California. I think this was about 200 different tests that they did, and they tracked where the problems were coming from. And you can see plugging and maintenance are the 2 highest things that cause problems, but there's other things. Fortunately, poor systems design is low on this list. In California, we're fortunate that most of our irrigation companies are amazing companies that do great design work. So you don't really see that as being a common issue. Topography, obviously, when you've got rolling hills, it's a more challenge to deliver water at the same amount to the top of the hills that you do to the valley. So that can be a challenge, and that's actually one that can be really hard to overcome, just inherent in the system. Mixed nozzle sizes. We see this a lot where there's MicroJet sprinklers in the field where over time have been repaired, and ones have been replaced that were clogged, and they were replaced with the wrong jet. That's a very common thing. Leaks in the system. To give you an idea of the impact of a leak, there was a filter station that Tehama County RCD tested, where it was a Morrell filter, a screen filter that had a gasket, and the gasket was leaking, just dripping. They put a catch can under that and captured how much water was dripping off that gasket. And it didn't look like much when you just stand next to it. But across the season, it was over 10,000 gallons of water were being lost to that one leaking gasket. So another place where we're losing water that we're not getting beneficial use from. So other areas that cause problems are not flushing your system. And I love these photos. They really illustrate it well. The first photo on the left is a submain flush valve that they opened to flush the system. They let it run for 20 minutes, and this is what they got. Just a bunch of gunk. And this is all gunk that was continuing through the system and could be clogging the sprinklers at the same time because it was going through the system. And then you can see, obviously, the discharge on the right is not clean water. So just going through and flushing systems. Other flushing issues on tubing. A lot of debris and organic matter can build up in tubing. So flushing is a very important thing. And here's some examples of things that are coming out of tubing. All these cause problems with uniformity. More clogging. Riser screens are really common, but here's drip tubing that's all clogged up. So this drip tubing is not performing as design spec because it's clogged with materials. So flushing the system out. And these are things that you'll discover by doing a uniformity test. So we're going to look at what this impact, just visually, what it might mean. So here's a row of trees, the water source is on the left, you see the direction of flow, and we're just looking subsurface at the root zone. Our goal is to really have this consistent delivery of water so the depth of water remains consistent. So all the trees are getting the same amount of water. But when you have challenges like plugging or pressure issues, you get in this situation where the trees at the end of the row aren't getting enough water. And unless you address the root cause that caused this problem, the only way to solve getting enough water to the trees at the end of the row is to over-irrigate the trees at the beginning of the row. So when we think of this, trying to meet the goal of a 20% reduction on water use, here's a simple way where we're just over-irrigating to overcome a challenge that we could address. This can be pretty severe in some cases. And to further illustrate, we'll look at this 4-block irrigation system, an example of the impact this may have. So here's 4 irrigation blocks. The radius circles illustrate the spray patterns of the MicroJet sprinklers. And we're going to zoom in and look at this 3rd block that we've discovered problems by doing a uniformity test. There's a number of things going on here. The first thing is we come in, we follow the pipeline coming from the pump and then into the submain, into the first row of the block. All these trees are getting pretty consistent water, but we move in the 2nd row where there's a clogged riser screen. Such a simple thing, a $4 part that's clogged with organic material, and it's blocking the flow through that line. And you can see the smaller diameter wetting patterns as the flow and pressure falls off. So this hurts us in 2 ways. One, we're wetting a smaller wetting pattern because we've got less pressure going through that jet to distribute the water out into a proper spray pattern. So the wetting pattern's smaller, water's getting to the smaller part of the root zone, and we're delivering less water. And as we go further down this submain, we see the last few rows are getting really inconsistent application of water to the very last row where it's really getting severe because the pressure's falling off. There's not enough pressure in the irrigation line to deliver the needed pressure to meet the design spec of this MicroJet. So you see these last two to three rows are getting much less water than the other trees in this block. And when we do a uniformity test, we'll go out and take readings in multiple quadrants of the orchard, both pressure and flow, so we can identify where the weak and problem areas are. So when we look at this from an application rate, and we're looking at this MicroJet at the design spec, we can see it was designed to run at 25 psi, and that gave you a 19-foot radius that sprayed the water in, and almost 16 gallons per hour as far as what it was delivering. But at 10 psi, it fell off to 10 gallons per hour and a 13-foot radius for its wetting pattern. So pretty severe fall off. And this is a place where doing this kind of evaluation can really help. And it's why it's really the foundational and the key practice we encourage growers to do first in the irrigation continuum to make sure their system's running really efficiently. And going back to our goal of this, one of the four Almond Orchard 2025 goals, reduce the water to produce a pound of almonds by 20%. Irrigation efficiency and distribution uniformity is one of the primary areas that we really can see big improvements that directly go back to our profits, what our pumping cost is, what our water cost is, what our nutrient cost is, and evenly distribute so our yields are consistent across the orchard. It's an area that I really encourage growers to look at. We want to help with this, so the field outreach team do evaluations for growers, as well as we partner in the Almond Board's funding a few RCDs in the state to offer this as a free service to our growers. So closing thoughts, following the steps of the continuum really helps you progress over time with a clear path to improvement, evaluating your irrigation system every 3 years at least, but every couple of years will really help find those problems where you're having problems in the field, so you can address them and get your system back up to working at its maximum. And you don't need to do this alone. Contact myself or Ashley Correa, or reach out through field outreach at almondboard.com. We're really here to help. We're your team in the field to help you with uniformity testing, as well as just being a sounding board. If you have problems in the field and need some advice on who you should reach out to get help with this problem, or what to do with rootstock, who's the farm advisor in my area that could really help me with the rootstock selection, we really want to help with that.